All right. Sorry, I didn't know I was muted. I'm recording. Let's see how many people are here. We only have 8 here. Let's go ahead and look at what the assignment is for today. And then I'll take roll. Since people are starting to come in. We're going to talk about geometric sequences today. Yesterday we talked about arithmetic sequences. We don't have school tomorrow. That's kind of cool. No school tomorrow. So I guess I won't see you guys tomorrow. I told my class I'll see you tomorrow, but I won't see them tomorrow. Okay. We're doing assignment number 54, 7.3, analyzing geometric sequences, page 378, 5 through 49 odd. There's a lot of them. And then we have 7.3, check your understanding. So that's our assignment. Let me take rolly roll. Okay, Donnell, Javier.
Here.
Isaac Aquino. Ishi Blanco. Madison Boyer.
Here.
Kayla Bradley.
Here.
John Chovola.
Here.
Alex Garcia.
Here.
Jasmine Godinez. Matthew Gonzalez.
Here.
Brandon Grijalva.
Here.
Morelli Hanon.
Here.
Jeshua Hernandez.
Here.
Annika Hulskamp.
Here.
Eric Jones.
Here.
Gracie Marcelo.
Here.
Carlos Origel.
Here.
Jose Orozco.
Here.
Ethan Ramos.
Here.
Natalia Rodarte.
Here.
Jaylene Ruiz.
Here.
Giovanna Ruiz.
Here.
Taylor Simmons.
Here.
Jay Singh.
Here.
Gianna May Takeo.
Here.
Jacob Terrell.
Here.
Roberto Valdez.
Here.
Ariana Villalobos Castillo.
Here.
Okay, I have Isaac Aquino, Ishi Blanco, and Jasmine Godinez absent. Isaac Aquino. Ishi Blanco.
Here.
Jasmine Godinez.
Here.
Okay, so Isaac, you're not here? Okay. All right. So let's rock and roll, I guess. Okay. Oh, sorry, it's all black because my document camera is not on. There we go. Okay, here's the assignment that we got here. Hey, oh. Okay, so make sure you write that down. 54, 7.3, analyzing geometric sequences, page 378, 5 through 49 odd. Okay, I already had that up before, so I won't hold this up too long because assuming that you guys already wrote this down. But we're doing geometric sequences. You guys remember arithmetic sequences where they increase by addition or subtraction? Actually, it's all addition. Sometimes you just add a negative number and it decreases, right? Will they all increase or decrease by the same number? Well, let's take a look at this. what is a geometric sequence rule? Okay, the geometric sequence, remember they had the arithmetic sequence rule? We'll write this down. The geometric sequence rule is this. A to the n equals a to the 1 times r times n minus 1. So write that down. That's important. Our whole, well, like 90% of our lesson is based on that rule. Now, the thing is, all we need is the first term, and now instead of the common difference, we need the ratio. Those are the two things. That's all we need. Once we have the first term and we have the ratio, so let's write down what this is. This is the first term. It's the first term. This is the ratio. Okay, that's the ratio. And then n is the term, right? Okay, that's the term. But we leave that blank. So make sure you have this written down, though. It's a to the n equals a to the 1 times r raised to the n minus 1 power. Now, here is an example of a geometric sequence. We have 5, then we have 15, then we have 45, then we have 135. The first term is 5, the second term is 15, the third term is 45, the fourth term is 135. So can you see what's going on here? And go from 5 to 15 to 45 to 135. This is a geometric sequence.
Each number is getting multiplied by 3.
Yes, very good, Jay. We're multiplying by 3. 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. Now, that's important. Again, the two things we need are the first term and the ratio to figure these out. The first term of this is 5. So my a to the 1 is equal to 5, right? My ratio is the number that we multiply by. Sometimes we multiply by a fraction. But it's obvious, you can see I'm multiplying by 3, so my ratio is 3. So my rule, since I do have the first, all I need is the first term and the ratio, my rule is going to be a to the n equals the first term times the ratio raised to the n minus 1 power. And that's it. That's this lesson in a nutshell. That's all you have. That's like the main thing you have to do. All you do is say, hey, the first term and the ratio. So for this, like for example, if I want to figure out what the fourth term is, I plug 4 here. 4 minus 1 is 3. So 3 to the third power is 27 times 5, and you get is 135. Plug in 4, you get 135 into that equation. So that's it in a nutshell. Are there any questions before we move on? Okay, let's do number 5. So that's that. Let's do number 5, and then look at what we got. Let's look at the homework. We'll look at number 5 in the homework. Let's look at number 5. Okay, number 5 says, tell whether the sequence is geometric. Explain your reasoning. Okay, so now we have to tell if the sequence is geometric or not. So here's how you do. Here's what you do. So number 5, is this geometric? We have 96. Then we have 48. Then we have 24. Then we have 12. Then we have 16, and we go on. No, sorry, we have 6. Sorry, not 16, we have 6. 6. Then we go on. All right, is this geometric? Oh, no. What do you think? Look at that term. What do you think, Joshua? Do you think that's geometric? What's your gut tell you?
I think it is.
Yeah, it is. Do you know why though, or?
Oh, because it's like multiplying by 0.5.
Yeah, we're multiplying by half or 0.5. Very good, Joshua. Way to knock that out. But let me show you how the book shows you how to figure this out. Here's how you figure it out. Remember, we did figure out the ratio. The ratio for this is 1/2, but let's say we don't know. This is the first term. This is the second term. This is the third term. This is the fourth term. This is the fifth term. Let's call this A1, A2, A3, A4, and A5. Now, to figure out the ratio, you go like this. A2 divided by A1. And then let's figure out A3 divided by A2. And then we figure out A4 divided by A3, and then A5 divided by A4. Let's see what happens for each one of these. A2 divided by A1 is 48 divided by 96. A3 divided by A2, whoops, let me go here. A3 divided by A2 is 24 over 48. A4 divided by A3 is 12 over 24. And A5 divided by A6 is 6 over 12. Now we can divide these, simplify, and get a decimal, but a lot of times in the book and on your quizzes, they like to reduce the ratios. Reduce. These are both divisible by 48, which becomes 1/2. These are both divisible by 24, which becomes 1/2. These are both divisible by 12, which becomes 1/2. And these are both divisible by 6, right? We're just reducing. Becomes 1/2 because all of my ratios are consistent. They are the same. They are 1/2. If any one of these are different by the ratio, then it is not geometric. But what that shows is my ratio, 48 times 1/2 is 24. 24 times 1/2 is 12. 12 times 1/2 is 6. Because this is all times 1/2 times 1/2 times 1/2 times 1/2, and my ratio is consistently 1/2. This is, yes, it is a geometric sequence because it has a ratio of 1/2. That's all you have to do for those. Just set it up, divide the one before the other, the one before the other, the one before the other, or the one after the other. You divide this one by that one by that one, that one by that one, that one by that one, and then if they're the same, then it's a geometric sequence. Are there any questions on that? Okay, I'm going to move on. I'm going to get rid of this in 10 seconds. 5, 4, 3, 2, 1. Okay, now let's go ahead and look at, so this is like 5 through 12. I did the easiest one. If you want me to do a harder one, you can ask me after class, but it says see example 1. It's just the only thing is, like some of these you just have to divide fractions. 1/6 divided by 1/2, then 1/18 divided by 1/6, 1/54 divided by, you just multiply by the reciprocal. Okay, let's go to these. Let's go to 15 through 22. Write a rule for the nth term of the sequence. Then find A7. Okay, so let's do 15. 15, what's the rule? 4, 20, 100, and 500. Now, you can already see the ratio. I'm sure some of you can. Remember, our rule, there's our sequence. You can probably already see the ratio. Remember, it's a to the n equals a to the 1 times r raised to the n minus 1 power. Now remember, all we need is to find the first term, and then we have to figure out the ratio. Well, we have the first term here, it's 4. So we'll say a to the 1 equals 4. Got that? So now let's figure out the ratio. Now remember, this is the first term. This is the second term. This is the third term. This is the fourth term. So we do our rule to find the ratio. Remember, we find the ratio, we go, the ratio is a to the 2 divided by a to the 1. The ratio is a to the 3 divided by a to the 2. Let's just make sure they're consistent. So I'm gonna do more than one, right? A to the 4 divided by a to the 3. A to the 2 divided by a to the 1. 20 divided by 4 equals 5. Okay. A to the 3 divided by a to the 2. 100 over 20 equals 5. Well, what do you know? Right? And then a to the 4, 500 divided by 100 equals 5. So guess what? Now I have my ratio is equal to 5. I have the two things that I need. So what's my rule? What color should I do? I don't know. I guess I'll do it in a to the n equals, what's my first term? My first term is 4 times, my ratio is 5 raised to the n minus 1 power. And that is our rule. That's all you got to do. We just need the first term in the ratio. And we can check it. We can plug, let's plug in 4 to see if it works. I should get 500, right? So let's say a to the n equals 4 to the 5th times 4 minus 1. A to the n equals 4 to the 5th raised to the 3rd. Now make sure you do the exponent before you multiply. 5 to the 3rd is 125, I believe. Yeah, it should be 5 to the 3rd is 125. So it's 4 times 125. Should get 500. And you get 500. So I just checked it. Now they ask us to find a to the 7th. Okay, well, let's find a to the 7th. The 7th term. A to the 7th equals 4 times 5 to the 7 minus 1, right? 7 minus 1 is 6. 5 to the 6th power times 4. Woe is me. A to the 7th equals 62,500. That's your answer. That's my 7th term. Can you guys see that? So that was 15. Kind of a lot. Are there any questions? Remember, you need the first term in the ratio. That's all you need. First term in the ratio. Okay, since there are no questions, I'm going to move on in 10 seconds. 5, 4, 3, 2, 1. Okay. That was 15. Now all these again, I did the easy one because the main thing is finding the ratio, right? This one, what is this? Dividing by 2. So this is 1/2. This one is, I don't know, what's the ratio on this one? Whoa, I don't know. 6/4. What is that? 3/2. This is 1/2, right? And then you just plug it in. If you need, ask me after class, I can help you with that. Now let's look at 23 through 30. It says write a rule for the nth term of the sequence, then graph the first 6 terms of the sequence. So this one, I'm not given the first term. This one I was given the first term, right? 15. But I'm given the third term. and I'm given the ratio. Okay? So 23 is, you're given a to the third equals 4, and we're given R. It's a pirate's favorite letter. 'Tis the C. You heard that one before? Okay. Remember, so I'm given the R. Our equation is a to the n equals the first term times the ratio raised to the n minus 1. So I got the ratio. I just have to figure out the first term. Okay. So here's how you figure out the first term. You use your rule, and you plug in everything except for a to the 1. So we have this, we have that. So a to the n, watch what I do for a to the n. Instead of a to the n, I'll do my a to the 3. A to the 3 is equal to 4, but I'm writing this, right? Equals a to the 1, which we don't know what a to the 1 is, times r, which is 2, times 3 is my n, so I plug 3 in here. 3 minus 1. Okay, so I plugged in everything. Now remember, a to the 3 actually equals 4. So I'm going to say this is 4 equals, right, a to the 3 is 4. So you really want to put the 4 here. Okay, I don't know. I just think it's easier. I won't do that extra step anymore. I think it's easier for us to see, put that there, then it becomes 4. But anyway, a to the 1 is 2 to the second power. 3 minus 1 is 2. So all this is 4 equals 2 to the second is 4 a to the 1. I just brought this here. Now solve for a to the 1. I divide by 4. A to the 1 equals 4 divided by 4 is 1. Now I have my a to the 1. I have my r, which equals 2. I have my a to the 1, which equals 1. That's all I need, right? So my rule is a to the n equals 1 times 2 to the n minus 1. Or 1 becomes, right? Don't need the 1 there. 2 to the n minus 1. That's my rule. There you go. That's 23. So what did I do? I just plugged in everything into my rule to figure out my a to the 1. Again, like the examples in the book, like you can use those to help you figure it out. You can use the examples in the book. Again, I did the easy one. If you want me to do a harder one at the end of class, I will. Okay? Does it ask for anything else? Right, roll the nth term of the sequence, then graph the first 6 terms. Okay, we got to graph them. Okay, got to graph the first 6 terms. I'm going to get out my graph paper. So 23 continued. 23 was a to the n equals 2 to the n minus 1, right? That was our rule. Is that our rule? Yeah. A to the n equals 2 to the... So I got to graph the first 6 terms. So here we go. Whoa, sorry. Okay, so I'm going to graph these. Now they want the first 6 terms. Let's make a little table here. So here is our term. Here is our term solved. 1, 2, 3, 4, 5, 6. I have to graph the first 6 terms. Plug in 1. 1 minus 1 is 0. 2 to the 0 is 1. Plug in 2. 2 minus 1 is 2. That's 2. 3 minus 1 is 2. 2 to the second is 4. By the way, my rule is multiply by 2, right? So each of these are going to increase by 2. 4 times 2 is 8. 8 times 2 is 16. And then 32. Any questions on how I got those numbers? Six terms. Now I got to go up to 32. So I can't fit 32 here. This is my N. This is my A event. So I'm going to increase these by 4, 4, 8, 16, 20, 24, 28, 32. All right, let's go ahead and graph. Any questions on how I got those to graph it? The first term is 1. So 1 will probably be like right about there. I don't know, I'm just estimating. The second term is 2. That'll be halfway. The third term is 4. That's easy. 4 is right there. The fourth term is 8. There. The fifth term is 16. I feel like I skipped a number. I skipped a number, huh? That should be 12. Dang it. 12. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. This is why you should always do math in pencil. 28 and then 32. So then my fifth term is 16, which is here. I'll tell you why I saw that I made a mistake there based on how it looked. Then my sixth term is 32. Remember, you don't connect the dots, and it should look like that, ignoring this right here. That is not a point. No. The reason I knew this point didn't work is because look how it increases. It starts increasing really fast. That's what geometric looks like. It goes, it starts shooting up. The next one will be at 64, which will be way up there, right? It just shoots up super fast with geometric. It has that like shoot up kind of curve. That's what a geometric one looks like. Are there any questions on that? You guys alive? Okay. Morella, how you doing?
I'm good. How about you?
Good. Is it hard to pay attention?
No, not really.
Oh, that's good. I would think it would be. Annika, how about you? How are you doing?
Good.
Is it hard to pay attention? Be honest. I'm
No.
not going to be mad because I understand these meetings are hard to pay attention to.
No, I can just go on ahead and work while you're explaining it, so then it makes sense.
Oh, you're going ahead. Okay, that's good. Yeah, do what you need to do. How about you, Eric Jones? How are you doing?
Good.
I can't see you. Are you able to pay attention or?
Yeah.
Yeah? Okay. Do you feel like poking your eyeballs out with a needle?
No, not really.
Oh, that's good. I was in a meeting, I told you, like a Zoom meeting yesterday. They were using Zoom. I just wanted to poke my eyeballs out. And I was thinking, I do this to you guys. I just make you listen to me the whole time. Anyway, let's look at the next one that we're going to do. Eric, if you can turn your camera on, that'd be great. Okay, 23. So all of those are the same. You're given a term and then you're given the ratio, right? Now this one, you're just given 2 terms. So I'm going to do number 33. They say, what are the 2 terms? And so you're not given the first term, you're not given the ratio. 33, you're given a to the second equals 28. So the second term is 28. The fifth term is, actually, let me write it in orange. The fifth term is 1,792. What are they asking us? Exercise 33 through 40, write a rule for the nth term of the geometric sequence. So all we have to do is write the rule. The rule. Well, our rule I'll do in purple. A to the n equals the first term times the ratio, all of that raised to the n minus 1, okay? So I'm not given a first term, neither am I given a ratio. So here's what you do.
Mr.
Okay.
Sanchez?
Oh, am I not showing?
Yeah, you're not.
I'm sorry. Thank you for saying that. Present now. Okay, so again, let me show you what I was looking at. I was looking at this one. We're given the second term is 28. The fifth term is 1,792. I'll pause a little bit so if you guys can see what I've written here. So I have the second term is 28. The fifth term, this is supposed to be in orange, 1,792. And here's my rule. A to the n equals a to the 1 times r raised to the n minus 1. Okay. So this, we're going to write the equation twice. It's kind of like last time we were given 2 points, we used the elimination method. This we're going to use the substitution method. So a to the 2, I'll do the 2 steps. You don't have to do this, right? A to the 2, we're going to write here, which we're going to substitute with 28, equals a to the 1 times r, which we don't have, to the n minus 1, which is n is 2, 2 minus 1. And this one we'll do in orange, a to the 5 equals, remember we're going to switch this to 1792, equals a to the 1, r. Remember we need the a to the 1, we need the r. The 5 minus 1. Okay. So remember, a to the 2 is really 28. Next time I'm going to skip that step if I need it. This is just 28 equals a to the 1 times r raised to the 2 minus 1 is 1. And then this one, a to the 5 is 1,792 equals a to the 1 times r raised to the 5 minus 1 is 4. Okay, so all I did was I just plug them into 2 equations, okay? That's all I did. See what I did there? And I solved the 2 minus 1, the 5 minus 1. Now let's take this 28 equals a to the 1 r, and let's solve it for a. So it'll be 28 equals a to the 1, r to the 1 is r. Let's solve for a. Divide by r. 28 over r equals a to the 1. Okay? So my a to the 1 equals 28 over r. That means for this, I can substitute with 28 over r. Use substitution, and we'll just have r's. So I have 1792 equals, okay, a to the 1. I'm going to put in 28 over r, so I'll do that in the green. 28 over r times r to the 4th. Now, these are going to cancel out. This will go away, and then this will become 3. If you need me to explain that better, I will, but it does. What color should I do? I'll do it all orange now. 1792 equals 28. Now, this is r cubed. Divide by 28. Now I'm solving for r, right? I'm solving for r. Divide by 28. 1792 divided by 28. 64. 64 equals r cubed. Then I'll take the cubed root, and then I'll get r equals 4. R equals 4. Okay, well, we got the r. So let's go back. After all that, we have here, we have 1, we have r equals 4. Okay, now we need our a1, right? Now we need our a1. I don't think I'm going to fit it. Oh, can I fit it? I think I need a new sheet of paper here. Let me go like this. Let's fold this in half. Okay, so now put this on the side here so you can see what I'm doing. Let me recopy this. I have a to the n equals a to the 1 times r times raised to the n minus 1. I have r equals 4. Okay, now we're going to do what we did on the last one to figure out the a to the 1, right? That's what we do. We had the r, we just have to figure out the a to the 1. So you pick a point. I'm going to pick this one because it's smaller. A to the 2 equals 28. Okay, so this is what we did on the last one. So we're going to use this point. I'm going to say a to the 2 equals 28. Okay, so then we just plug in everything except for our r. Remember, a to the 2 we're going to put in here. So it's going to be, instead of a to the n, we're going to say 28 equals purple a to the 1 times r is equal to 4. 4 times, since I'm plugging in my 28, my n's going to be 2. So it'll be 2 minus 1, right? So the green, I plug in the green and the orange. That's going to allow me to solve for my a to the 1. So all we got to do is now just simplify. Let's clean it up. Easy. 28 equals a to the 1 times 4. 2 minus 1 is 1. 4 to the 1 is 28 equals 4 times a to the 1. Divide by 4. And 7 equals a to the 1. So now I have here my a to the 1. Should I hold that there so you guys can see? Sorry, I'm going fast. I'll pause there for a second. A to the 1 equals 7.
Wait, Mr. Sanchez, couldn't you have just done 28 divided by r?
Only if that works because this is a, you're using the a to the 2. So I guess technically you could do that because that eliminates this. This becomes 1, right? 2 minus 2 is 1. Let me think about that. So yeah, so that means, but if I didn't have a to the 2, you wouldn't be able to do that.
I think what Jay is referring to is, I know how earlier before we solved for r, we got 28 over r equals a1. Couldn't we have done that?
28.
Yeah, on your other sheet of paper. Right there.
Well, yeah, actually. So wait, let me think. That you could have done that. But I want to make sure that before I say the answer is complete, see if that works every single time. That only works because we're given the second term. So yes, if you're given the second term, you could do that. Because like if we're given this term, if I saw like if I took this, the 1792 and set this for this would be 1792 divided by r to the 4th. So that would be kind of hard. But yeah, so that works out. Only if you're given the second term. Okay, Jay? I don't know if you.
All right, thank you.
Let's look at the other ones and make sure you have that. But anyway, let's go and finish it up. Let's take it home. We have a to the 1 equals, what was it? 7. So our final rule is, I'm just going to write in one thing. A to the n equals 7 times 4 to the n minus 1. That is our rule. Now, just to make sure, I'm pretty sure that would work, Jay. But to check, see if it works, you plug in 5 into your equation, see if you get 1792. But let me see if these are all. What are you given here? This one you're given a to the 2, a to the 2. Look, so knock yourself out, man. If it works, try it. But make sure you check your solutions to make sure it works out. Okay, Jay? But I think it will work with a to the 2. All right, so these are the same thing. You just have to find a rule. You're just given points. Same thing, except instead of it looking like this, it looks like that. 41 through 44. And the last thing, and same thing with this, 45, you're just given a bunch of points. You're not given the first. But you're given the second term. Look at all these. You're given the second terms. Is this one? Are these you given the first? This one you're given the first term. So you're given the first term and the rate. That one's easy, right? Because you're going 4 to 8. The R is 2. The first term is 4. So anyway, hopefully if you're understanding what I'm saying, I'm talking very fast. But if you stop and look at that, I think you'll be able to figure it out. This one, you're not given the first term, you're given the second term. And by the way, you could figure out the first term by figuring out what you're doing and just putting in a 1 here, right? This one, you're multiplying by -2. So you divide by -2, and this one will give you the first term of 6, right? And you could say, oh, right? I mean, once you have the first term, you have the ratio multiplying by -2, you have your answer. Okay, last thing. Last thing. By the way, all that stuff that I said that didn't make sense, if you want me to re-explain how to do this after class, I will. Because I talked, if you get it strong, that all that stuff would make sense. If you're still like going, oh, it's going to make your mind explode. And I can be more gentle about that. I just don't want to spend too much time on the ones who get it. So the ones who don't get it, stay after. Let's hang out. Okay. Now, how about these summations here? That's what we're going to work on. Now, look at this. All the way up to the 9th term. Okay, so you have to plug in the first term, figure that out. Plug in the second term, figure that out. Plug in the third term, figure it out. Fourth term, all the way up to the 9th term, and then add them all up. Well, there's a shortcut. Here, hang on, I'm writing the problem down. Okay, now this only works if you have a geometric sequence. Can you guys tell that this is a geometric sequence? Because here you have your A1, here you have your ratio, and here you have your n minus 1. Okay, so this is a geometric sequence. This is a geometric sequence. A1, my ratio is a fraction, it's still a ratio, 3/4 raised to the n minus 1. This is also, so if you're given a geometric sequence, let's look at 47, that tells you to add all those up. Summation of I equals 1 to the 9th, 6 times 7 raised to the I minus. Instead of using n, they use I. Okay, here we go. This is what I got. Okay, if you want to do a summation of a geometric sequence, instead of adding all up 1 through 9, figuring out 1, figuring out 2, figuring out 3, all the way up to 9, right? That's our last term. Okay. Well, we use this. Okay, where I think you can tell a to the 1 is the first term. So all I have to figure out the first term. The r is the ratio. And then this is the sum. And this is the last. Right? That's the last n that we're going to use. Is the n is the last. And same with this n. This is the last. So we have an n here that's the last. So again, the n is going to be 9 because we go up to the n9 is our last n. That's our last n. That's our first term. That's our ratio. Okay, so the thing is we have to figure out the first term before we do all this. I'm giving you guys a second to write this out. This will be our last problem. Okay. So, let's figure out our first term. We want our first term, our last term is our ninth term. That's okay. Let's figure out our first term. That means we plug in 1 for our I. So we go 6 times 7 raised to the 1 minus 1. Okay, well, guess what? 6 to the 7th. 1 minus 1 is 0. What's anything to the 0 power? 1. Right? 7 to the 0 power is 1. 6 times 1 is 6. So guess what? That is our first term, a to the 1. Now, what is our r? What is our r? Well, this is the first term. This is the r, right? The r is 7. So, we're going to go here. S, okay, so hopefully everything's in my screen. We're going up to 9. Going up to 9 equals, okay, first term, A, is 6 times 1 minus r to the n. R is 7. 7 to the 9th power all over 1 minus 7. Any questions on how I set that up? Okay, 7 to the 9th. So let's first order of operations. So we do the parentheses. Inside the parentheses, we have an exponent. 7 to the 9th. Find 7 to the 9th power. Oh my goodness. Oh my goodness. Okay, 4. Can you guys see that? 40,353,607. So we're going to say that 1 minus that. 1 minus 40,353,607 all over 1 minus 7. All of that times 6. Okay, so 1 minus 4, like, what the heck? That's a very small number. 1 minus 40,353,607. We 606, right? So negative 40,353,606, right? We're taking away 1, but it's going to be negative, right? Because this is negative. So that makes that shrink up. 1 minus 7 is negative 6. Oh, can you guys see what I'm doing there? Sorry. 1 minus 40,353,000, that just becomes a 6. 1 minus 7 is negative 6. All of that times 6. So this divided by this times that is going to be 40,353,606 because those cancel out and makes it positive. So that's if you took the sum of, that's the sum of all this right here. Can you guys see? So the sum of this equals 40,353,606. That's if I took in 1 6/7 to the 1, and then 2 minus 1 times 6/7, then 3 minus 1 times, or 6/7, blah, 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 blah. Just add all those up. That's the shortcut. Are there any questions on 47? So make sure you write that equation down. I'll bring it back down in just a second. Make sure you have that before you check your understanding today. This for your check your understanding. Okay. I don't have anything else to show you. Are there any questions? Okay, if there's no questions, you may go. If you have questions you want to ask later on, you can go. Bye, Jasmine. Bye, Johnny. Bye. Well, everyone's leaving so fast. Eric, bye, Matthew. You guys are out of here like a bat out of where. Gracie, bye, Malia. Bye, Jose. Ciao, Jose. I like it. Bye, Roberto. Bye, Ariana. Bye, Giovanna. Oh, Giovanna. I don't know if you're staying. I thought it was waving. Okay. All right. All right. Let's see. Questions. Let's see. Let's go with Jay first, since I'm looking from left to right.
I had what if I in the summation notation was 3 or something like that? Because I had a problem with one of the questions in the quiz, the check your understanding.
That was for the arithmetic?
Yeah.
Okay. So can you give me the equation? Does anyone have a quick question before I go with Jay? Okay. All right. This will probably take a couple minutes. If one of you wants to get up and walk around or whatever, you can while I go over this with Jay. Okay, Jay, do you have the question written out?
No, I don't. Hold up. Let me
It was
check.
on the well, I could see if I can find it.
Yeah,
Hang on.
it's the 7.2 check your understanding.
Okay. Okay, I got it. Oh, okay. Okay, so that's a good question. You would just subtract the two. So first, you could just do the long way. It'd probably be easier just to do the long way, but I'll show you how you use the 5 equals I equals 3, and then negative 3I minus 7. Okay. Here, 1 second. Jay, give me 1 second. Okay. Wait, can you see what I'm doing here? Wait, I think. Okay. Okay. So what you're asking is this one right here, I believe, right, Jay? Or it's 3,
Yeah.
not
Yes,
1.
that one.
Okay. So there's a couple ways we can do this. One, we can just plug in 3. Let's have here a to the I, plug in 3, plug in 4, plug in 5, right? So you plug in 3, get negative 3 times 3 minus 7, which is negative 9 minus 7, which is negative 16. Then plug in 4, and each of these should decrease by negative 3. Negative 3 times 4 minus 7, negative 12 minus 7, and that is negative 19. And then this one will be negative 21. Wait, negative 22. Negative 22. Then you just go negative 16 plus negative 19 plus negative 22, and you just add them up. Okay?
Oh, okay, yeah, because I forgot what. So if I equals 3, then that's just the what I equals is the first term, right?
First term, last term. And I get negative
Oh, okay,
57.
yeah,
Now,
yeah, that's what I forgot. Yeah.
if you want to, you can use this though, because this one, it still might be crazy. We figure out 1 to 5, and then we figure out 1 to 3, and then you subtract them. So let's go. Do you want to see that way?
No, I'm fine. I get it now.
All right. But if you use this, you go, if you do the summation, you do the 5 here, like you plug in 5 and you go negative the first term to negative 22 divided by 2, and then you figure out up to 3, then you subtract them and you'll get negative 57. It's the other way. But okay.
Okay, thank you.
All right. Okay, let's go with Giovanna. What's up? You want to go later? I can't hear you. You're muted. Wait. I can't hear you, Giovanna. Do you want to go later? Are you muted? You're muted. Okay. Later. Okay, later. All right, Carlos, what's up?
Can you explain number 33 again? But like a
33.
little bit slower.
Okay, hang on. Where are we at? 33.
I had the same question, but my my thing wasn't working.
Wait, was that Giovanna that asked that?
Yeah.
I wasn't even looking.
Yeah.
Okay. Your microphone wasn't working?
Yeah, it was being all weird and laggy.
Okay. I know this tech stuff is crazy. It's lame. A2 is equal to 28. Okay, Carlos and Giovanna. I'm gonna go this. Should I go? I'm gonna go like medium fast, since I did this already.
Okay.
But slow me up if I'm going way too fast. Would that be okay if I did that, or do you want me to go slow, Carlos?
No, it's fine.
Okay. So all these equations. So we have here for geometric sequence, a to the n equals a to the 1 times r times raised to the n minus 1, right? That's what we want. We need the a to the 1. What is our a to the 1? And what is our r equal to? Am I not presenting?
No.
Okay. Sorry. Present, 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 present. Okay. my glare. Let's see if I can get rid of my glare here. Okay. So we need our A to 1, we need our R, right? Okay, so since we have 2 points, let's write 2 equations here. So let's do 28 first. 28 equals A to the 1. I don't know what A to the 1 is. I don't know what my R is. But I have my N as 2 minus 1. Any questions on how I did that? Carlos, you good?
Yeah, I'm good.
Okay. So now, how am I going to set up my next equation, Carlos?
1792 equals A sub 1,
Yeah.
and then R to the 5 minus 1. Sorry.
No problemo. Okay. So let's simplify these. 28 equals A sub 1 times R to the 1. 1792 equals A sub 1 R to the 4. Now let's get A by itself for this one by dividing by R. So for this, we're going to say it's divide by R. 28 over R equals A sub 1. Carlos, does that make sense? Ah! Okay. So now I'm going to take this A sub 1, 20 over R, and plug it into this one. So I'm going to say, write this equation, 1792 equals, instead of A sub 1, R to the 4th, I'm going to plug in 28 over R. Now what that does, since I substituted it, it gets rid of the A sub 1, and now I'm able to solve for my R, which is what I want, right? Carlos, you good so far?
Yeah.
So now these are going to cancel out, and this becomes 3, R to the 3rd. So it's 1792 equals 28 R to the 3rd. Divide by 28 to solve for R. Am I in the camera still? And then that's going to be, that cancels. 1792 divided by 28 is 64 equals R to the 3rd. You take the cubed root, and R equals 4. So now I have an R. There's a lot of steps. So let me review what I did. We plugged it into 2 equations. Then I solved for A, plugged this in for A. I was able to solve for R, solve. I got 4.
Okay.
What else do I need, though?
The A sub 1.
A sub 1. So, try to do it here. So then you just pick a point. I picked this one. A sub 2 is 28. You just plug it into your equation, but we also have an R now, right?
Yeah.
So A sub 2 is 28 for this equals A sub 1 times R is 4 times, raised to 2 minus 1. Giovanna, are you with us? Is this making sense or no?
Yeah, it's making sense.
Okay, so now I'm solving for A sub 1. Since I have the R and I have this, I could have used this too. I could have used this point. I would have got the same answer. 2 minus 1 is 1. 4 to the 1 times A1 divided by 4, is 7. So I got a sub 1 is 7. Do it right here. 7. So my answer is a of n equals 7 times 4 to the n minus 1.
Okay, yeah, I get it now.
It's just a lot of steps. And
Yeah.
it's kind of the same as the one we did with the arithmetic, but it's just a lot of steps. I
Yeah.
think the key thing that helps me is knowing that I need to figure out the a sub 1 and the r. You just got to find them, figure them out.
Yeah. Okay. Well, that's all I had to ask. Thank you.
All right, cool. No problem.
Bye, Sensei.
All right, see you later, Carlos.
You
All right,
too.
Natalia, what's up?
It was for the check your understanding. It was the same one that Jay did, except he show like how to do it with the equation.
Yeah, you want me to show you how to do with the equation?
Yeah.
Okay, let's do it. Okay, so let me write it here. Oh, here I'm sharing, so I might as well go right here. Okay, so let's rewrite it. I equals 3. Last term is 5. Negative 3i minus 7. Okay, so our equation is okay, here's what we're gonna do. To solve this, let's see if I fix my glare. It's getting worse as the day goes on. Okay. All right. Here's what we're gonna do. We want to go from 1 to 3. So what we're gonna do is we're gonna go like this. We're gonna go the summation of I equals 1 to 5 minus the summation of I equals 1 to 3. So what I'm doing here is I get the total of 1 plus 2 plus 3 plus 4 plus 5 after plugging this in. And then I'm going to subtract the 1 plus 2 plus, actually, I should go up to, I think I should go up to 2, since I want up to 3, right? I want to go up to 3. So I figure out 1 and 2, and then I just subtract those. And then I should get the same answer. So do you get the idea behind that? What I'm going to do before I do it, Natalia?
Kind of. Not really.
Okay, well, let's just do I'll show you how to do it, and then we'll just do it. So anyway, let's go from 1 to 5 by using this right here. 1 to 5. So I have to figure out my first term and then my last term. So my first term is, let's get my first term, is negative 3 times 1 minus 7 is equal to negative 10 is my first term. Then I got to figure out my last term is negative 3 times 5 minus 7 is equal to negative 15. Negative 22. Okay, so I got my first term, negative 10. Make sure I got that right. My last term, negative 22. So we're going to plug it in here. Okay, so we go up to 5. Do it in green. 5 is my n times my first term, negative 10, plus my last term, negative 22, all divided by 2. So that's going to be negative 10 plus 22 is negative 10 plus negative 22 is negative 32 divided by 2 is negative 16. Negative 80. negative 80 for that. So that's 1 through 5. Let's just do 1 through 2. Okay, well, I mean, they don't really need to do the equation for this, but we know the first term is negative 10. We just figured that out there. Now if we got the second term, well, I mean, we could just add those up. They're just 2 terms. But let's just do it anyway. So that's going to be, the second term is negative 3 times 2 minus 7, which equals negative 13. So that's negative 23, which would be negative 57. But anyway, let's go and plug it in. I'll do it in purple. Minus 2 times negative 10 plus negative 13, all divided by 2. Negative 23 divided by 2 is negative 23. Is wait, hang on a second here. Positive negative 23. Then we subtract them. It's 57. However, trying to figure out how to make it. Oh, I think we have to take away from the absolute value. Let me think about this. This has to be from the absolute value for some reason, and that will give us negative 57, which is our answer. The negatives are throwing me off here, though. Why? I wrap my brain around it to make it negative 57. So anyway, that's that in a nutshell. For this has to be the absolute value, negative 57. So that's your answer.
Okay, thank you.
You're welcome. Okay. All right, who's there? All right, Isaac, what's up?
My attendance might be absent.
Dude, you should have told me you're a quick one.
Oh, I wasn't paying attention. My bad.
You didn't have to wait this long. Why were you late?
No excuse.
Huh?
I don't have an excuse.
Were you late last time?
Yeah.
Okay, don't be late anymore. Well, so I'm just gonna mark you out absent or tardy.
Okay.
How late
thank
were you?
Like 2 minutes, I think.
Okay, it's not bad. Just don't do it anymore. All right, you're good.
Thank you.
Okay, I'll see you.
See ya.